Hi everybody, this is Michael from Professor Zare's Chemistry in the Kitchen class, and today I am going to be teaching you all how to make my family's famous white brownies. Fundamentally, white brownies work like normal brownies. The only major difference is that there isn't chocolate that's melted into the dough itself. Instead, at the end, you dump chocolate chips into the whole batch. What happens with these is that they end up forming a crust at the bottom, and you have lots of different texture as it melts and hardens at different rates, and you get lots of different browning, crust, all kinds of good texture. They're wonderful. You're going to love them. So the first step of our white brownie recipe is you start out with 2 cups of flour. Now this right now is 2 cups, and I just pre-poured that because you don't want to have to sit there watching it. Flour is, of course, the base of every cake and flour-based concoction, although, of course, with this one, flour is not the #1 ingredient. Sugar is. This is the essential secret to why our family white brownies are so delicious. For your flour, the first thing you add is, again, pre-measured out, 3/4 of a teaspoon of salt. The salt is there effectively just to add substance to the flour. Flour will have much stronger gluten networks form in the presence of salt. And to add to the mix here, we're going to add in 1½ teaspoons of baking powder. Now, baking powder is distinct from baking soda, which is just sodium bicarbonate, in that it has a weak acid in a powder form, often cream of tartar added in advance. So like the salt that I added into this, the baking powder as it stands currently does nothing. The baking powder and the salt are just being sifted by this, relatively crude process, obviously, into the flour. That baking powder is going to end up interacting with hydrogen in the bake to create air bubbles. This is going to give you that nice light texture that you want in a cake, while making sure that the pH isn't all messed up, because it turns out that baking powder is a pretty universal neutralizing agent as well. This is why, for instance, baking powder ends up being useful in cases of chemical spills. So with the magic power of editing, that just got sifted. And so next up, you have to break your eggs. Now, again, I like saving your time, and that's why that step is pretty much done. Now it's totally done. That's the right way of breaking an egg. Now, it turns out that there was an absolute miracle, which is that there was no eggshell that was left by that last disaster. And so I didn't actually end up having to sift through this as badly as I thought I would. What I'm doing now is I'm beating these, and I'm beating the egg yolks and the whites right together. And as you can see, we're having the consistency of this change pretty rapidly. What's happening is that the long proteins in the egg white are unfolding under manual pressure and reforming, basically hydrophobic ends connecting, and you have this longer matrix that we can end up integrating into more complex things, which we're about to do using the power of sugar. This is what it looks like, by the way, when you beat eggs properly. Thank you so much to my wonderful editor and assistant, and wonderful inspiration for showing everyone how to beat eggs properly.
Doesn't that just look gorgeous, folks? We love to see it.
Now, like I said, the flour, as you can see, is a pretty major ingredient in this. The sugar is the #1 ingredient. We're putting in 3 cups of sugar into this. And so, first we look for the fork that we were using. So we're very slowly beating in this white sugar, and it is making this wonderful emulsion. Now, the water that's in the egg whites is now more or less bound up with the sugar that's been added, and that water will be persistent in the final concoction. That's why you need to make sure that you have sugar in your baked goods, or you will end up with very dry, unappealing dessert, and really no one wants that to happen. Now, you need flour for your baked goods, because otherwise you won't really have baked goods by any conventional measure. The flour is your basic carbohydrate that you're using, and it's nice, relatively complex compared to glucose carbohydrates that can form pretty long strands. Now, you've heard of vegetable shortening, which is You know, typically you see it in large cans in grocery store. And you may wonder where the word shortening comes from. Well, what fat does in a very real way in baking is it shortens the strands of gluten that are going to get formed in our baked goods. That means that we're not going to have stuff that's too dry, too crumbly, all kinds of textures that you really don't want to have in your food. And it makes sure that you've got that rich texture, rich consistency that you want in brownies, because really, if your brownies aren't a little bit overindulgent, why? Why? The last of our liquid ingredients is vanilla. Well, vanilla extract. And chemistry is the theme of this video, but we're not putting in vanilla for any particular chemical function. It's more or less an inert ingredient. What it's there for is that delicious flavor, and that's why we put in 3 teaspoons. Vanillin is distinct from other benzene-based. Oh my, taking me out. B, look at her. Oh God, if that wouldn't distract you, that's just, come on, fella. Who's a good boy? Take vanilla. And vanilla is a real shame to waste because it's relatively expensive, because it's really good stuff. It is an aromatic compound structured around a benzene ring with 3 functional groups. Those functional groups are what distinguishes vanillin from all the other not as tasty smelling aromatic compounds that may or may not be spilled over my stove right now. In the case specifically of vanillin, you have aldehyde, ether, which is not ethyl. That's the thing they used to put in gas, which would be really bad to have in your brownies.
And hydroxyl.
And thank you. Now we've got all the liquid ingredients, and now it's time to add in the dry, kind of slowly incorporating it one bit at a time. And we want this to incorporate nicely, but we don't want to stir it up too much over time. The reason for that is because the more that we work this now active wet solution, it's got your gluten, your gliadinins going on, and because water has activated essentially the reaction, we're already, while this is happening, the gluten network is getting more and more strong. That's how we want it, because we want nice, chewy, kind of gooey, delicious brownies, but we don't want that to go too far. So now we're going to skip ahead to the point where this is beautifully incorporated. So we've been a couple minutes away, and you can see that the flour is now more or less incorporated throughout this. We've got a nice, thick, almost creamy texture that's going to make a really beautiful body for these white brownies. Now we've got just one last step, and it's the one that I sure have been looking forward to. It's time for the sweet, delicious chocolate to go in. So we're going to bring this all together and just scoop this in, and look at that absolutely beautiful combination of sugar, of fat, of flour, of all those things we want. There's just one thing that's missing: the power of browning. But before we get the power of browning, it's time for the chocolate. Now this bit is more or less to taste, and I know how I prefer it. It's how I've been doing it for a long time. I use a little bit, I would say a little less than 1/2 of this bag. And you can see I'm not worried about them being clumped up together. They're going to spread out. You can already see that's happening. And I'm going to use my spatula, spread them out further. Now you may think that these are going to end up sinking to the bottom, and you would be right. For the most part, these will sink to the bottom. And you're going to have a delicious, complex, crusty matrix of delicious chocolate and sugar that's all been melted together and that has browned for different amounts of time. Further ado, B, it's time to move because you don't want to get burned.
B, come here. Come here, baby. Come here.
We believe in you, B. You can do it. Yes, who's a good girl? And you just drop that right in the oven. Beautiful. So it's been maybe a hair over 35 minutes, and so I'm going to take this out of the oven And oh my God, look at that. Oh, just look at that. Huh. Okay, apparently the bottom of my oven is not exactly level. And the result of that is that it's all going to have cooked a bit differently. But the good news is that this is fully cooked. There's, the egg is absolutely going to be finished in this. And so I'm going to just take this knife and I'm going to test this end of it. And there is a tiny little bit of cake left. And because it's got this thick portion, I'm going to take this back in and turn it around. And I'm going to leave that in for another, we'll say, 3 or 4 minutes. And once that's all taken care of, we'll see how it comes out. Hey guys? For time, given the whole, mishap with the surface of the pastry here. However, oh my God, yeah. This is pretty exquisite, actually. You can see the top is firm. That is the product of all that browning that has taken all of this once entirely ordinary pastry, sugar, and turned it into a perfect, delicious white brownie. And so the best way to do these, you want to serve them, is you want to cut these right away. And that might seem kind of counterintuitive, but you really do want to get these cut as soon as you can. And then you can leave them in the pan. That way you're going to have the nice fall off from the melty, gooey inside. You're going to have nice defined edges, and it's going to come right out of the pan easily. As you can see, this area is a little bit underdone, but at the end of the day, this is going to be exceptional. And I am going to offer the first of it to my absolutely magnificent assistant, Ray. Now, just take a look at that side view. You can see you've got all these wonderful little air pockets. That's the product that's just catalyzed by the baking powder that we put in there. Now, Ray, I mentioned aromatic compounds. How does it smell, folks?
Amazing.
And lastly, I mentioned the crust at the bottom. Now, let's see how that came out.
Perfect.
Perfect. Look at that. It is nice, it's solid, and you're going to have out of this world.